Good morning guys, Anjani Kumar here, dealing power system 2 for third year electrical students. In the last session, we discussed about different types of insulators, right? We just started, right? What are the different types of insulators, right? So basically, the successful operation of a transmission system that can be designed by choosing a type of insulators, right? So that's why basically the insulators are classified into four types. So what are those? Pin type insulator, right? Strain insulator, suspension type insulator, Schottky type insulator, right? One more type is there, that is egg insulator. We don't have that much concept of egg insulators in our syllabus, right? In a last session, we discussed about pin type insulator. I'll give a brief glimpse of pin type insulator, that what we discussed. Right, basically the pin type insulator that can be designed, that can be developed, manufactured with porcelain, steatite, glass, or whatever it may be. Basically we are using porcelain, right? How the pin type insulator will look like, I already discussed about all this information. So this can be used for less than 33 kV. So that can be used in a distribution system itself, right? So if you go for more than 33 kV, these type of pin type insulators that are more economical, right, which is having a porcelain layers, right? So top of this on the top we can call it as a groove, so where the conductor is going to be connected, right? So these are the things that we discussed in the last session, right? So there is a chance of failure occur in this type of a pin type insulator. What are the chances? Means there are two chances. The first one is a flashover and the second one is a puncture, right? What is a flashover? Flashover means each and every porcelain layer must be as smooth as possible, so that we can call it as a glazing. That means each and every porcelain layer on the pin type insulators, those are as smooth as possible, right? If it is a rough surface, what happens? The dust particle will be stayed on the porcelain layer. So then what happened? These dust particle combined together, it forms like a conductor, right? So when the current flows from the groove, that can be enter into the dust, and it will enter into the cross arm, and it will enter into the pole. So definitely what happen, if a person touches that pole, definitely will get a severe electric shock. So this is this phenomena we can call it as a flashover. So the time taken for the flashover is a very large. That means it will take around, all the dust particle will be filled over the porcelain, so it will take some time, right? So it will take some time. So due to that current, the pin type insulator will get heated. After that, the insulator will get destroyed. So these phenomena we can call it as a flashover. After that, what is a puncture? So you will see what is a puncture means. I clearly explained. The puncture means this is a porcelain layer now. So these are the porcelain layers, right? So you have to fit the groove. Groove is nothing but steel one, right? You have to fit this groove. ఎప్పుడైతే ఈ ఫిట్ చేస్తున్నావో, there must be a welding process. The porcelain will get some cracks, right? The porcelain, whatever the porcelain layer, will get some cracks. So with that, what happened? Definitely your insulator will be divided into two parts. One part is like this, another part is like this. So you have a groove, so which is directly connected to the pin. So where the pin is connected to the cross arm and your cross arm is connected to the pole. So then what happens? If the insulator starts destroyed, whatever the current conductor over the groove, the current will directly transfer from here and to pin after that cross arm, and it will enter into the pole. So when the person touches the pole, definitely will get severe electric shock. So these are the chances of a failure that occur in a pin type insulators, right? So but that's why we need to maintain safety factor, right? Safety factor in a pin type insulator. So what is the safety factor? Safety factor is equal to flashover by puncture, right? This is a formula we need to maintain while designing your pin type insulators, right? So this is very important. What is the safety factor for a pin type insulator? So that is nothing but 10. So what is the safety factor? This is a very important gate bit, right? The safety factor for a pin type insulator is a 10. So these are the things that we discussed in what are the advantages, but it is very less cheaper, it is used in a distribution system, right, and more life. Nowadays we are using these type of insulator in a distribution feeders, right, local distribution systems, right. So beyond disadvantage means beyond 33 kV it is more economical, right. Chances of chances of occurrence, failure occurrence will be very high in these type of pin type insulators, right. These are the things that we discussed in the last session. Today we'll discuss about all the remaining insulators, because the pin type insulator is very important. That's why I've taken one class for this, right. Now today we'll discuss about suspension type insulators. One more category is there, that is called a suspension type insulator. Like a pin type insulator, the suspension type insulator also made up of a porcelain, right. So each and every insulator will be made up of a porcelain, right. And the suspension, the name itself indicates, the suspension means వేలాడతీయడం, right. So suspension is nothing but వేలాడతీయడం. So this is a way of suspension type insulators, right. You will see like this, right. Each and every suspension type insulator which is having number of disk, right. So each and every disk represented 11 kV, right. So these are one disk, this is one disk, this is one disk. So itla వేలాడదీయడాన్ని we can call it as a suspension, right. This is called a suspension type insulator. So where the top, which is nothing but cross arm, here we'll see this is the cross arm, and where the pole is connected here, you are fitting your suspension type insulator. I'll explain one more time. So this is your cross arm now, where your pole is going to be connected here, and you have to put your discs, right, like that, where the conductor is connected on the bottom of the, so your conductor is connected on the bottom of the suspension type insulator, right. So this is a conductor and this is a cross arm where your pole is going to be here. So these type of insulators we can call it as a suspension type insulator. Suspension is nothing but వేలాడతీయడము, that means horizontal, not vertical, horizontal. You will see each and these type of suspension type insulators that can be used for greater than 33 kV. So less than 33 kV, what type of insulators that we are using? Pin type insulator. If greater than 33 kV, that is nothing but transmission, 62 kV, right, 132 kV, right. All these things, these are high transmission. So for this we require these type of suspension type insulators that can be used for a long transmission lines. You will see in our college one high power transmission system is there na. So where you can see these type of insulators, right. Each and every like each and every disc that are going to be connected in series and placed in a horizontal, right. You will see in your real life while long transmission system which is having more voltages, right. So each and every disc represents 11 kV. But suppose if there are how many discs? There are 3 discs. That means how much voltage the conductor can carry means 3 into 11. That means 33 kV line is going to be carried. If number of discs are increases, for suppose there are 6 number of discs, so what about the voltage that the conductor will carry means 66 kV. So this is nothing but suspension type insulator. I'll discuss one more time. The suspension type insulator is nothing but the suspension. The name itself indicates suspension means swinging, like means వేలాడతీయడం అనమాట, right, which is having more number of discs, right, which are connected in series and placed horizontally, right, and placed horizontally on the top of and the bottom. So on the bottom of the suspension type insulator we are connecting the conductor, right, on the top which is connected to the cross arm. So where the cross arm which is connected to the pole. So this is where the suspension type insulators are going to be designed. So on what voltages these type of suspension type insulator that can be used? Those are greater than 33 kV, right. So that is nothing but 62, right, 132 kV. So these are the transmission system that we are using these type of suspension type insulator. In your real life also you will see ఫర్ ఎ లాంగ్ ట్రాన్స్మిషన్ సిస్టమ్ దగ్గర చూసారంటే దీస్ టైప్ ఆఫ్ ఇన్సులేటర్స్ యూ విల్ సీ బాగా కిందకి వేలాడదీస్తున్నాం. సో ఎంత వోల్టేజ్ దట్ కండక్టర్ విల్ క్యారీ మీన్స్ బై సీయింగ్ ద ఫిగర్ ఇట్ సెల్ఫ్ యూ విల్ సే. సో హౌ మెనీ discs is there? There are 3 discs. So how much voltage that can carry? 33 kV. Easily you will say. Or else if the number of discs are 6, that means which is carrying 66 kV. That means one disc, one disc, one disc, one disc, one disc, one disc. So all the discs where the conductor is going to be transferred here. So how many voltage that can carry? That means 66 kV. You will directly say. So what is the voltage that transmission system can carry means 66 kV. You will directly say. So this is about suspension type insulators, right? You will see how the suspension type insulators are, right? So in this way the suspension type insulator, here there are number of discs are how many discs? So 3 discs. So where the cross arm is connected and the pole is here, your conductor is going to be ground like this. So this is a suspension type insulator. So the maximum voltage these type of insulator that can carry means 33 kV, because how many discs? There are 3 discs. So that's why this is a 33 kV. So beyond 33 kV, whatever it may be, if the number here you will see. Here how many discs? 1 2 3 4 5 6 7 8 9 10 discs. So that means around 1100, 11 into 10. So 11 into 10, that means 110 kV of line that can carry these type of insulators, right? So this is the design consideration. These are number of discs that which are connected horizontally, right? So this is about suspension type insulator. Now I'll discuss what are the advantages of it. What are the advantages of these are the different types of this is nothing but cemented cap insulator. Cemented cap insulator, we don't have that much concept on this. This is core type insulators, like each and every we are not using nowadays these type of suspension type insulators, right? So there are core type and cemented type suspension type insulators, right? We don't have that much concept on this. Nowadays we are not using these type of insulators. Now we'll see what are the advantages of suspension type insulators, right? What are the advantages of suspension type insulator? Right, the first advantages, so which is used for a transmission system, that means greater than 33 kV. So distribution system, what type of insulators that we are using? Only pin type insulator. For a transmission system we are using suspension type insulator. Next, second one. All right, if any disc got trouble, so it doesn't have any total insulator, that means not affects the total insulator. All right, so this is one more advantages. That means if any discs got trouble or cracks in that, definitely there is no problem about the remaining total insulator, right? So if any disc got damaged, it doesn't mean the insulator will not destroy, right? And the third one, if the load on the line is increases, right? If the load on the line increases, what happens? You should directly connect one more disc into that. But suppose this is a 33 kV, right? I want 44 kV, right? What happened? Definitely you should remove and should connect another one. So you don't go for a new insulator, right? You just modify that insulator and put one more disc for higher voltages. That means, I think the point is clear, right? So first one, it is used for a 33 kV transmission system. So greater than 33 kV, that is nothing but a transmission line that we are using. And the second one is, if any one disc got damaged, it doesn't mean that it doesn't affect total insulator, right? And the third one, if the load on the conductor is increases, that means if the voltage on the conductor increases, right, directly you need not to go for another type of insulator. You just add one more disc for that, then only you can easily construct. So that is one of the advantages. These are the advantages. And one more advantage is, if the conductor is going to be connected at the bottom part, right? This conductor is going to be freely swinging, so which is having less mechanical stress on that. That means the conductor which is easily swinging, which is it doesn't have it doesn't get tightly connected. It's like a swinging, so the chance of occurrence of faults are very less. So this is one more advantages while designing your suspension type insulators. Right, these are the advantages that one more time I will explain all the advantages. The first one is it is used for greater than 33 kV. Okay. Second one is if one disc got trouble, no need to it doesn't mean to total insulator destroy. Like third one, if the load on the conductor increases, you just add one more disc, you just two more discs that are going to be added to that insulator, that's it, no need to replace total insulator, right? And the fourth one is the conductor which is connected to the bottom of the string, so which is bottom of the disc, that means the conductor is going to be freely swinging, right? It doesn't have any stress on that. Freely swinging means less chance of less mechanical stress, that means less chances of occurrence of faults in that type of a conductors, right? So these are the advantages of suspension type insulators. I hope it's clear about how the suspension type insulators that are used in your transmission system. You will see your nearby transmission system which is carrying 66 kV, 132 kV. You will find these type of suspension type insulators, right? Each and every disc represented by 11 kV. So with that you will define so how much voltage that the conductor will carry, right? So this is about suspension type insulator, right? Now we'll go for strain insulator, right? Yes, each and every pin type insulator, suspension type insulator, strain insulator, these are made up of porcelain itself. We are not using glass and steatite, all that materials. We are not using polymer. We are not using, because these are temperature dependent. If the heat is going to be generated, my whatever the materials, glass or polymer or a steatite will get melt. So that's why we are not using those type of materials. So we are using only porcelain material, right? So what is a strain type insulator, right? So the name itself indicates strain is nothing but tension on that line. So when the tension on that line happen, so we need to protect that line from the tension itself. For suppose if there is turning, if there is any turning happen, definitely there will be a stress on that conductor, na? So on that situation we need a strain type insulator. I hope it's clear. When turning, river crossing, right, or mountains, so all these are height positions, right? Turning, river crossing, height positions, definitely there will be a tension on that conductor. So due to the tension that can be availed, the tension can be eliminated with the help of these strain type insulators, right? So this can be used for a whatever the voltage it is. If it can be used for 11 kV voltage, so that we can call it as a Shackle insulator, right? We'll see, right? When the dead end, that means lost end, when a dead end, river crossing and turning positions, definitely we require some tension on that line. So that can be avoided with the help of these strain type insulator. For a low voltage, that means less than 11 kV, so these type of insulators that we can call it as a Shackle insulator. We'll discuss in the next session, in the next category of type of insulator, right? Less than 11 kV, this is nothing but Shackle insulator, right? Strain type insulators are nothing but the suspension type insulator itself, but we are placing suspension type insulators that we are placing horizontal, but these type of strain type insulators that we are placing vertically. This is the difference between strain and suspension type insulators. We'll see how the strain type insulators that are going to be this, right? These are strain type insulator, right? Is there any dead ends or turning points? Turning points are happening. So these type of these are like a suspension type insulators, but what you have, you are placing these type of discs in a vertical positions, like the tension on the conductor that can be reduced with the help of these type of insulators, that we can call it as a suspension type. That means that we can call it as a strain insulators, right? You will see if the tension on the line is very much high, so what happen, you have to place number of sessions, right? So this is nothing but so how much tension means how much voltage that can carry means how many disc, 1 2 3 4 5 6 7 8 9, that means 990, 9 into 11, so 99 kV line. So that means is there any turning point that much of tension is going to be present? So in order to avoid this is a strain insulator. They can horizontal go, this we can call it as a suspension type insulator. ఇంకా స్ట్రెస్ ఎక్కువగా ఉందనుకో, హౌ యూ కెన్ మేక్ దిస్, యూ విల్ సీ ఇన్ యువర్ రియల్ లైఫ్ ఆల్సో. సో ఇంకా స్ట్రెస్ ఎక్కువగా ఉందనుకో ఏం చేస్తావు, ఇక్కడ ఇంకొద్దిగా ప్యారలల్గా సస్పెన్షన్ టైప్ స్ట్రెయిన్ ఇన్సులేటర్ని కనెక్ట్ చేస్తావు. ఇంకా ఎక్కువగా ఉందనుకో ఇంకా ప్యారలల్గా. సో దీస్ టైప్ ఆఫ్ connections you will see in your real life, where dead ends or a crossing of a large transmission system. In that situation you will see these type of strain insulators that are going to be present. So what is the main difference between suspension type insulator are going to be horizontal position, whereas strain insulator that can be placed in a vertical position. So that is a difference between a suspension type insulator and strain insulator, right? But suspension type insulator that can be used greater than 33 kV, but strain type insulator that can be, you can use it anywhere, right? If it can be used for 11 kV also, less than 11 kV also we can use these type of strain insulator, but that we can call it as a Shackle insulator, that we discussed in a next type of insulators, right? So if the tension on that line is even more, so then what happened, you have to make another strain type insulator connected in parallel. If it is even more, another more which is connected. If the tension is very high, if it's very difficult to clear that tension, that means you have to put another type of strain insulators, right, connected in parallel. If it is inka ఎక్కువగా ఉంది, another type of insulator. So likewise you have to connect these type of strain insulators that we are connected, right? This is about strain insulator. You will see that these are the figures, like I think this is used for less than 33 kV. Also we use these type of strain type insulator, right, where there is a dead end, a river crossing, or height positions. In that situation the conductor tension is very high. So in order to avoid these type of tension, so we are using strain type insulator. The name itself strain type insulator, right? So less than 11 kV, these strain type insulators we can call it as a Shackle insulator itself, right? Yeah, it can be used for more than 132 kV also, but that means the tension is very high. In that situation you have to place a parallel type of strain type insulators, right? So what is the difference between suspension type insulator and strain type insulator means, the suspension type insulators that are going to be placed horizontally, strain type insulator that we can place vertically. That's it, that's the main difference, and both things are same. Each and every disc on that is 11 kV, in that also 11 kV, right? If the stress is even more, you have to place parallel positions, right? This is about strain type insulator. Next we will go for so these are the strain type insulator, where this is for greater than 33 kV, right? So these are the practical examples that we are using, and where the conductor which is having vertical place, that means where the insulator that can be placed horizontally or vertically. So it's like a vertically, so that we can call it as a strain type insulator. If the conductor placed like this, we can call it as a suspension type insulator. Where the strain type insulator that can be used, where a dead ends and river crossing and height distance, where the tension on the conductor is very high. So that means if the length of the conductor is very large, that means the tension is very high now. In that situation also we use these type of strain insulators, right? So this is about strain insulator. After that we have a Shackle insulators. So this is a real type old model of a strain insulator that what we used. And the last and final model is a shock kill type insulator. So what is a shock kill type insulator? So this we can use in a less than 11 kV the strain insulator that we can call it as a shock kill insulator. Alright, you will see in a distribution system at 11 kV, less than 11 kV, you can see these type of insulators, right? What is meant by shock kill insulator? In early days, the shock kill insulator were used as a strain insulator, right? I said earlier, right? 11 less than 11 kV, your strain insulators we can call it as a shock kill insulators, right? So whatever the low voltage distribution, that means less than 11 kV, we are using these type of shock kill insulator, right? This can be used either horizontally or either vertically, right? This can be fixed to the pole. How the shock kill insulator will look like means this is the shock kill insulator. You will see this type of insulator ni pole ki fix chesestam. So this is this we can call it as a pole. You will see in your street poles, at the street poles పోల్ ఇలా ఉందనుకో దీనికి ఏంటంటే ఒక ఇన్సులేటర్ని ఫిక్స్ చేసేస్తాం. ఇట్లా ఇక్కడ ఒక ఇన్సులేటర్ ఉంటుంది, దీని గుండా కండక్టర్ పాస్ అవుతూ ఉంటుంది. యూ విల్ సీ ఇన్ రియల్ లైఫ్, రైట్? హౌ షాక్ కిల్ ఇన్సులేటర్ లుక్ లైక్ మీన్స్ దిస్ ఈస్ ద షాక్ కిల్ ఇన్సులేటర్. ఇక్కడ బోల్ట్ ఉంటుంది, బోల్ట్తో పోల్ని ఫిక్స్ చేస్తాం. ఇక్కడ నుంచి కండక్టర్ వస్తుంది. సో ఇక్కడ నుంచి కండక్టర్ వచ్చి వెళ్ళిపోతూ ఉంటుంది, రైట్? సో దిస్ ఈస్ ద కనెక్షన్ ఫర్ ఎ షాక్ కిల్ ఇన్సులేటర్. So how the shock kill insulator means it can be used for a low voltage distribution system, right? Where which can be fixed to the poles itself, like figure like pole ki fix chesestam anamata, right? This can be used for a distribution system like less than 11 kV, right? So it can be placed either horizontally either vertically, right? Nowadays we are using shock kill insulator for distribution of street pole. At the street pole nowadays we are using these type of shock kill insulator. So these are the different types of insulators that we studied, right? The first one is a pin type insulator, which is used for pin type insulator which is used for less than 33 kV. So beyond 33 kV it is more economical, right? Uneconomical, there is a chance of failure occurrence, that is called a flashover and puncture. So these are the things we need to consider while designing the pin type insulator. And we studied about safety factor. What is the safety factor of a pin type insulator? That we can call it as a 10. So this is about pin type insulator. And after that, what is that suspension type insulator? The name itself indicates suspension means veladathiramu. That means it's like a horizontally. So it can make horizontally, where the bottom which is connected to the conductor and the top which is connected to the cross arm, where the pole is going to be connected here. So each and every disc that we can call it as a 11 kV transmission, right? Each disc we can call it as a 11 kV. So these type of suspension type insulators that we can use greater than 33 kV. So less than 33 kV we can use a pin type insulator. Greater than 33 kV we can use these suspension type insulators, right? So by seeing the suspension type insulators, you will say how much voltage that can conductor carry. You will see. So what are the advantages of suspension type insulators means this is used for a transmission system. If any one disc fail, no need to that doesn't mean all that insulator will get damaged, and after that if a load on the conductor is increases, you need to add one more discs, right? That's it. No need to replace all the insulator itself, right? That means the conductor at the bottom end which is swinging, right, it doesn't have a fitted position. That means the chance of occurrence of faults is very less. So those are the advantages of suspension type insulators, right? And the third one is a strain type insulator. So what is a strain type insulator? Strain is nothing but tension at the dead end or river crossing or sea ends, a long distance, height distance. So tension on the conductor is very high. So in order to avoid the tension, we require these type of strain type insulators, right? It can be used any type of voltages. So it can be used for less than 11 kV. So we can call it as a shock-kill insulator. We discussed shock-kill insulator. If it is greater than, it can be placed as it will be like a shock-kill it will be like a suspension type insulator, but we can place vertically, not horizontally. Alright, so suspension type insulator ని horizontal గా పెడతావు, సేమ్ థింగ్ strain type insulator ని vertical గా పెడతావు. That's it, nothing difference is there. If I tension on the line even more, then you have to conduct one more strain type insulator that are connected in parallel. That means tension తగ్గిస్తూ ఉంటుంది. If it is even more, you have to connect like this. Right, in this way the strain type insulator that are going to be designed. For a low voltage, it can be act as a shock-kill insulator. For high voltages, it can be act as a suspension insulator, but it can be placed vertically. Right, you will see or in your transmission system where the dead end or a crossing that are happening in the system, you will see these type of strain insulator will be present on the system. And after that, we discussed about shock-kill insulator. Shock-kill insulator means pole-mounted insulator, right? So which is directly connected to the pole. It may be horizontally or vertically. It can be used for less than 11 kV distribution system, less than 11 kV. In olden days, these strain insulator we can call it as a shock-kill insulator, but nowadays, so we are using pole mounted insulator, right? So pole ki direct ga fix chestamu like this. The insulator will be insulator will be placed here, the conductor will be rolled. You will see the figure itself. So these are షాక్-కిల్ ఇన్సులేటర్. ఇక్కడ చూసారా, పోల్కి ఫిట్ చేసేసి ఉంటాం. సో ఇక్కడ నుంచి కండక్టర్ వెళ్తూ ఉంటుంది. సో దీస్ ఆర్ పోల్కి ఫిక్స్ చేసాం. పోల్ ఫిక్స్, దట్ మీన్స్ ఇట్ క్యారీ లెస్ దెన్ 11 kV, 440 volts, 430 volts అండ్ ఆల్ దీస్ థింగ్స్, రైట్? సో దిస్ ఈజ్ అబౌట్ షాక్-కిల్ ఇన్సులేటర్, రైట్? చూడండి, ఇక్కడ నుంచి వైర్ వెళ్తుందా? సో దిస్ ఈజ్ ద conductor, right? This is the insulator which is connected. So from this, ikkadi nunchi current podu kada, ikkadi nunchi you have to connect like this, right? So this is about shock-kill insulator. And one more insulator is a egg insulator. We are not using egg insulator is nothing but for a pole safety. If any conductors damage, వాటిని బాగా వైండింగ్ చేయడానికి we require these type of egg insulators, right? We'll see how egg insulator will be look like. Means స్టే టైప్. సో ఇట్లా చూసారా, దీస్ టైప్ ఆఫ్ ఇన్సులేటర్స్ వీ కెన్ కాల్ ఇట్ యాజ్ ఎగ్ ఇన్సులేటర్. అంటే పోల్ని సపోర్ట్ చేయడానికి ఒక వైర్ గ్రౌండ్ చేసి ఉంటారు, చూసారా? సో దీస్ టైప్ ఆఫ్ ఇన్సులేటర్ వీ కెన్ కాల్ ఇట్ యాజ్. ఎప్పుడైనా ఈ కండక్టర్ కానీ డ్యామేజ్ అయినా వాటిని పర్ఫెక్ట్ పొజిషన్లో చుట్టడానికి దీస్ టైప్ ఆఫ్ స్టే ఇన్సులేటర్స్ని యూజ్ చేస్తాం. బట్ దిస్ ఈజ్ వెరీ లిటిల్, నాట్ దట్ మచ్ ఇన్సులేటర్, జస్ట్ ఫర్ ఎ సేఫ్టీ పర్పస్ దట్ యూ ఆర్ యూజింగ్, లైక్ ఇట్స్ లైక్ ఎగ్ ఇన్సులేటర్, రైట్? ఎప్పుడైతే కండక్టర్ డ్యామేజ్ అయిందనుకో, ఈ ఎగ్ ఇన్సులేటర్ తిప్పి మనం వైండింగ్ చేస్తూ ఉంటాం అనమాట. సో దీస్ టైప్ ఆఫ్ ఎగ్ ఇన్సులేటర్స్ దట్ we are using. So these are the different types of insulators that we discussed till now. It's very, very important. That's about different types of insulator. In the next session, we'll discuss about what is a string and what is a string efficiency and all these things, right? Thank you for now.